Hey guys, we're doing part 2 of making stoichiometric problems easier. If you guys haven't watched part 1, I recommend you go back just because we go through the steps in which we handle these problems. But I wanted to start today's problem with the important rule is that when we're doing stoichiometric problems, it is easiest to always convert to moles before making further calculations. Okay guys, so then the two equations we're going to be using today is firstly concentration. So I just drew the triangle there, is that we have moles there at the top, we have volume over here, and we have concentration. So then the equations that we have is concentration is equal to moles over volume, which is directly from the triangle. Volume is equal to moles over concentration, which we won't be using today, but is quite an important one. And what's it called? Moles is equal to concentration times volume. Okay, also I just wanted to make an important note of the standard units that they use, is that remember concentration is always measured in moles per decimeters cubed. So if it's given in something else, so let's say moles per centimeters cubed, we have to convert it to moles per decimeters cubed first. And volume is always going to be in decimeters cubed, guys. So same thing with that. We always have to, convert it back to our SI units or our standard units before we can continue. And then the other one we did in the last video, which is mass. So I'm going to go over it quickly. The two important formulas we need is moles is equal to mass over relative atomic mass, and mass is equal to moles times relative atomic mass. Okay, so now that we have those, let's dive straight into the problem. The problem in question today is how much mass of sodium chloride or NaCl is made by reacting with 100 centimeters cubed of 2 moles per decimeter cubed of hydrogen chloride or HCl with excess sodium hydroxide or NaOH. And then I've just put the relative atomic masses there so that we can use that further in the question, because we're going to have to give the mass of NaCl. Okay, so the step 1 of our thing is that we have to convert all of the units into standard units. So here they gave us 100 centimeters of cubed. And as I said, volume is measured in decimeters cubed. So we have to convert it into decimeters cubed. And 100 centimeters cubed, you divide it by 1,000 to get to decimeters. So you get to 0.1 decimeters cubed. And then the concentration is in moles per decimeters cubed. And if we look back, that is the correct unit. So we don't have to do anything with that. Okay, so step 2, we need to write a balanced chemical equation. And this one's a very basic one. The only thing that's kind of tricky is that you need to know that the OH and the H come together to make what's called water. And then you see it's all 1 to 1 to 1, which I put down here. So it's just HCl plus NaOH makes NaCl plus H2O. Okay, so very basic equation. So now we move on to step 3, which is we have to calculate the moles of the compound in question. So we have 2 moles per decimeter cubed of 100 centimeters cubed, which is 0.1 decimeters cubed. So we can work out the moles of hydrochloric acid, which is equal to, using this equation here, concentration times volume. So we say it is 0.1 because that's the volume in decimeters cubed, times 2, which is the concentration in moles per decimeters cubed, which gives us 0.2 moles. Okay, so now that we have it in moles, we can now do our ratio calculations. Okay, so first thing we do is we write down the names of the compounds that we need. So we have HCl, and we need to find NaCl, so we write those down. The ratio is nice and simple, 1 to 1. So we just put 1 to 1, and then we put 0.2 because we know how much mass of HCl is there under the HCl, and we put X under NaCl because we don't know what that mole is, and we need to calculate that. Then again, cross multiplying, it's very simple. It's 1 times X, 1 times 0.2. So then therefore X is equal to NaCl, which is, the moles of NaCl, which is just equal to 0.2 because it's 0.2 times 1. So we have 0.2 moles of NaCl. But we're not quite done yet. It's because the question asks us how much mass of NaCl is made by reacting with 100 centimeters cubed of HCl. So now, because we only have the moles, we need to use this equation here. Mass is equal to moles times relative atomic mass. So we go mass is equal to moles times relative atomic mass. So we say 0.2 times, and then we need to see how much what's the relative atomic mass? So there's one NaCl, so we say 23, and one Na, so we say 23 because we get that from up there, and we say plus 35.5 because there's only one Cl, which we also get from up there. So it's 0.2 times 23 plus 35.5, which is 58.5. So 0.2 times 58.5 gives us 11.7 grams, and that is the end of the question.